Hello, we're Angie Wu, Emily Hack, Grace Ying, and Harrison Ferlauto, and we're 4 seniors studying biomedical engineering at Duke. We're currently in BME 460, Devices for People with Disabilities, a class where students are paired with an individual or organization and tasked to build an assistive device. Our device, the Kneader Feeder, is an assisted feeding device that enables our client Mary to eat more independently. Mary has severe ataxia due to a childhood brain injury. This means that she has difficulty coordinating her muscle movements, notably in her upper extremities, which makes it challenging for her to perform basic actions such as eating. Currently, she requires physical assistance from a caretaker during meals because her tremors make it difficult to smoothly move food from the plate to her mouth. This clip shows Mary's current setup for eating. As you can see, her hands are shaking even as her mother guides her hand from the cup to her mouth. Our device seeks to improve Mary's ability to scoop food without dropping it, as well as provide stability to her upper body, thus enabling her to eat as independently as possible. Our device, the Kneader Feeder, consists of a dampened feeding arm that reduces her tremors along with additional components to improve her overall eating experience. The 4 components are the dampened feeding arm, the modified utensils and utensil attachment, the rotational plate platform, and the left-hand peg. The first component, the dampened feeding arm, is composed of an anodized aluminum rod and 3 dampers. It allows for vertical and horizontal movement for scooping while minimizing Mary's tremors. At the end of the dampened feeding arm is the utensil attachment component. The spoons were modified into shovel-like shapes with a flat end and walls to prevent food from slipping off. The shovel spoons and the forks were additionally angled for horizontal attachment, as well as for picking up or scooping food off of a plate. As you can see, the utensils and the attachment mechanism are easily removed and cleaned. The rotational platform is magnetized to allow for plate attachment. The rotational component allows Mary to access all of the food on her plate during a meal. Lastly, the left-hand peg provides Mary's body with stability while she eats. Next, we'll be demonstrating setup of our device.
To prepare for use, the device is simply placed on a table and clamped down with 2 C-clamps to ensure that the base does not move while the user eats. These clamps can be easily tightened by spinning their rotating component until the bottom part reaches the table. Next, the plate platform should be attached to the base via the wooden block using 2 metal pegs. These pegs get inserted into 2 holes on either side of the plate platform that line up with 2 holes on the wooden block. This guarantees that the plate has a stable base to sit on during a meal. A magnetized plate can then be placed on top of the platform. Next, a utensil can be attached to the leftmost end of the dampened feeding arm using the supplied wing nut. Ta-da! Now you can use the device to enjoy a meal. This demonstration shows a user eating with our device. To scoop food off the plate, the user pulls the feeding arm towards her so that the attached utensil drags along the plate, picking up food. She then lifts the feeding arm to bring the utensil to her mouth. To prove that our device is functional, here's a video of our client using it. As you can see, Mary is able to eat almost entirely independently with this device. Her tremors are significantly reduced as she uses it, allowing her to easily scoop food and bring it to her mouth. Mary's caretakers only have to intervene a few times per meal to rotate the plate platform as needed. When asked about the device, Mary said, "I like the Kneader Eater because it helps me control my hand so I can eat by myself. I feel more stable because I can hold on to the left handle. I think it helps me eat by myself, which is really cool. It's better because I can feed myself." After a week of long-term testing, which is where all of these videos came from, one of Mary's caretakers also commented, "The process of setting up and switching the utensils, plates, and the platforms is easy. I think it's a great device, and I'm thrilled that Mary is feeding herself." Overall, the Kneader Feeder helps our client Mary, and potentially others, eat more independently. By allowing the user to eat with less assistance, our device encourages better nutrition, facilitates socialization during meals, and increases user confidence. To recreate our device, it would cost approximately $300. Finally, we would like to thank our professors, Kevin Caves and Chelsea Salinas, our TA Amitha, our clinical advisor Laura Jewell, Steve Earp and Greg Bumpass, Sertronics Inc., and Mary and her family for all of their help with this project. Thank you for watching!